All right, and now we are on to the RBD copy on read clones in the kernel RBD client. We're joined by Min, and ostensibly Lee will be joining as well. So Min, would you like to give an overview of your blueprint, and we can get started?
Okay. Good morning, everyone. I will introduce a copy on read in kernel RBD client. We have discussed RBD copy on read in previous CDS. And this time, we will discuss how to implement it in kernel RBD client. As we know, network latency will be the bottleneck of reading object not exist in clone because it will read object from parent. We will use the same algorithm of copy and read in RBD, which I implemented in GitHub. The algorithm is sample fascinating. We just find if the object exists in clone. If they do not, we should read it from its parent. If it exists, we just read it from. Secondly, after we got the object from parent, we just write it synchronously with CLS callback method, and so after it is written in clone, we just finish the whole process. In addition, no matter the data range, we just read the entire data from parent. I think copy and write implementation is a good example for me to implement copy and read, because then the two all need to read data from parent. I think in kernel RBD we just to make sure where to implement the copy and read. I think in the function RBD image object request submit, which process the RBD driver IO request from BIO. Josh, I need your suggestion.
Yeah, I think that's probably the right place to start, since that's the function that kind of kicks off the highest level I/O operation. I think I haven't. It might be a little bit of refactoring you might need to do to make the lower level calls work, but I think all the changes will probably just be restricted to like those RBD image object request and RBD object request functions within RBD.c.
Yes.
And right now the kernel client does not support fancy the striping version 2, so you don't have to worry about the extra striping things that you did in user space, which is nice. Let's see. One question I had about this was how you thought it should be configured. Like in user space, there's a ceph.conf option. So for the kernel, I suppose it could be like an option perhaps when you map the image.
Yeah, we could add a mount option with our existing options mechanism. That would work.
In my opinion, I will add some code in RBD image of object local summit.
Uh-oh, did we lose him?
We need more cables going across the Pacific. Hey, Josh, what's the status of the user space side copy on read patch? I see that there's a v2 pull request open.
Yeah, I think there's still a couple problems with it. I need to post more detailed comments on it. It's mostly just relating to the fancy striping and cleaning things up a little bit.
Okay, I'm interested in like cosmetic stuff.
Requests.
But, it's not that complicated, actually.
Yeah, just getting the striping stuff correct, and just a little bit more difficult.
Yeah. Well, is that gonna? I mean, one of the next things up for Ilya is doing the fancy striping on the kernel side. I mean, we're gonna face ultimately the same complexity there.
Right.
Ilya, do you have a sense of whether it's going to be easier to do one before the other?
Well, I don't want to sort of backstop. The fancy striping is a much bigger thing. So if they implemented it in time, say for this release, and it works well, not for this, for the next kernel release, and it works well, all right with just the chunking mode that we have, then we'll merge it, and I'll have to deal with it. And otherwise, it's the other way around.
Yeah. Well, I'm guessing. I mean, conceptually, it's pretty simple if you're just doing chunking. So that'd probably be.
Yeah. Well, chunking, it's really simple. Yeah, just pull up the object unconditionally. Don't have to do anything.
That would probably be my preferred route.
Yeah, I guess one other component is that keeping track of all the outstanding writes that aren't being blocked by like other requests, and making sure that they complete before the device can be closed or unmapped.
Right, because the normal, like we need to make flush wait for all these effectively.
Yeah.
Well, maybe not. Or close. There needs to be some other variant of flush.
Yeah, unmap.
Yep. And what happens if you read from something? It triggers the. I mean, is the idea that before we satisfy the read, we actually do the whole promotion, and then we do the read from our newly written child, or would we actually do the triggering read from the parent, and then immediately follow that with the promotion and?
I think the keyword there was synchronous, as far as I understood it. So,
what does the other one do? The user space.
So for user space, as I suggested, doing it asynchronously, so that the reads wouldn't be slowed down too much.
Yeah, but the first read at least wouldn't be.
Yeah. They'd still slow down, like read the entire object, which is slightly slower perhaps than reading a small chunk of it, but they wouldn't have to wait for the entire write. And that's why the user space version has some code to wait for all the requests at the end on image close. So for kernel RBD, it could just be we use the like image in use counter and like increment that for each. Read that as a ref count for each object we're copying up from this.
So you actually could close it while those writes were still in progress effectively. Like there's no need to, but the structure would stick around in memory. right?
Well, you
That's
just
what
wouldn't be able to unmap it.
Oh, yeah, okay.
I will ask some questions.
Sure.
The first, does RBD client leaks version stable?
Sorry, I didn't hear that. What was the question?
RBD client is RBD client stable?
Yes. It's pretty stable. Yeah.
Sometimes I encounter some error like mount error.
An error where you couldn't mount, is that what you said?
Just is my Liberty copy on read region 2 still has some problems?
Yeah, I'm sorry I haven't reviewed it yet. I still have like a few comments to make on it. I think there's still a couple of things to fix. With the fancy striping at the handling at the end of the read, and with using the XList to hold all the completions for the image close. But I'll comment on GitHub.
Maybe you should comment in GitHub, and I will.
Yeah, I'll comment on GitHub soon.
Do you think about the distribution lock if two RB clients access the same image? How to avoid leakage?
So if two clients access the same image with and are doing this, so using this copy of operation is actually safe, since it only it aborts if the object ends up already existing when it's actually run. So if multiple clients have them in flight, only the first one will be done. The second one will just return success without actually writing anything.
If the first client failed because of some reason, but it does not release the lock, and the second client can log the images. So how to process this situation?
For RBD locking?
First RBD client failed, but with HANA.
Wait, so I guess right now, like, the RBD locking is kind of more of a manually set up thing. It's not kind of automatically managed yet. I guess in general, if there was a higher level like service that was managing the locks, it would be able to determine whether like the actual user of the image was still using it or not, and if they were not, then break the lock and blacklist the old client so that a new client could use it.
And when I implement the copy and read in Clara RB client, it supplies a asynchronous completion lock, just as the LibRDB do.
Oh yeah, the completion lock makes sense, I think. Yeah, the kernel client might have some slightly different different locks required. But something similar in the kernel would make sense.
Yes. I've asked another question. It's, how does the function RBD image or object callback return data to BIO and VFS?
Let's see. I don't actually remember off the top of my head. I have to look at the code. I think it might just have the pointers to buffers in it, which are then passed back to the BIO, or reference the buffers in the BIO. I forget. Ilya, do you remember off the top of your head?
I missed the function name and the question in general.
He's asking about RBD image object callback and how the where the data gets back to the BIO.
Yes, how to return data when RBDIO ends.
The written data?
Yes, we know data is input from VFS, and when RBD driver processes it, and it will return the data back to VFS.
So you want to know how the data is essentially goes in or goes out? Goes in via the there is a list of BIOS that is attached. Well, not attached, but there's a list of BIOS, and it's not the VFS. It goes through the BIO interface because it's a plug device, and it returns the data. I mean, we have similar. The VFS is not involved here. I mean, we are in the VFS. All the VFS stuff is done by the kernel automatically. We just have to provide the basic BIO interface and.
Okay. And
it's already provided. There is, if you want to sort of have the central function is the RBD request FN or something like that. Yes.
Yeah, it's the one that takes BIOs off the queue and.
Yeah, RBD request FN. It's around line 3000. So you can take a look. It's essentially a central dispatch function that the VFS is one layer above it. It's
okay. And Josh, I also want to know the OBJ REQ flags like OBJ REQ loan and OBJ REQ exists.
I mean the device flags. Oh, right. Yeah, those are used kind of to determine whether just maintain some information about the block device for the kernel. It's just a I guess the general mechanism there is just to like determine whether the if it's a map snapshot, whether that snapshot still actually exists or not.
Okay, and some other flags. OBJ REQ BIO and OBJ REQ request pages. What are the difference between them?
So the pages versus the BIO list, right? So the BIO request BIO ones are basically used for it's for passing down. Yeah. So this is the part where we're basically deciding which part of where the data is going to be stored by the OSD client at the below the RBD driver. So we pass down either we put together or add in pointers to the BIOs, or if it's a request coming from the block device directly, or if we're doing a request to the parent image, we'll use a list of pages that's just writing into a buffer that we've allocated ourselves, and that's when we use the page list.
BIO means data from very fast or upper, and request page means data from OSD.
So they both get the data from the OSD.
Okay.
I think it's
basically
like
just
in the case of a read, it's either going into a BIO if it's initiated by a client, or if it's going to the page, it's a copy up.
The page is basically something that we initiated, that the block driver itself initiated, and the BIO is used when it's the client. Then the IO was initiated by the client, so the block device was opened and then read or written to. Whereas the page lists are used when we initiate IO ourselves, such as the copy up. So.
Yes, I know it using copy up.
Yeah, so for the copy and read, I think we'd probably want to do the pages and then copy a portion of that into the BIO for the actual read.
Okay.
Does that make sense?
Yes, thank you. This is all my questions.
Okay.
So we got about.
Are there other questions we need to answer, or do you think you're in good shape? I think you dropped off for a couple minutes, but we were talking about just sequencing of the copy and write support in the kernel versus the support for striping in the kernel, and if we can move forward on the copy and read quickly, then it makes sense to get that in sooner. So we're definitely interested in helping move this along over the next month or two. And we can move a lot of these technical questions onto the mailing list too, or IRC. We're always there to answer questions.
Okay. Are we all set on this one?
Okay.
All right. Sounds like it. We will
All right, I think so.
continue on.